All right, so this week we're going to be going over unit testing in Python. So let's get started. So testing in Python. There's a few different ways that we can test in Python. One of the most common and what we've done so far is manual testing. And this is just manually running through our code with various inputs and observing the outputs to ensure that they match our expectations. This is basically what we've been doing so far throughout the course, is we just take our code and we generate a number of inputs that we expect our code might encounter. And then we just run the program and then manually check ourselves that the outputs are what we expected. This is relatively simple and intuitive, but the downside to it is that it's time consuming because each test requires crafting different inputs and then digging through the outputs manually to verify our functionality. If you make a change, then you need to manually test each scenario again. So it can be hard to define all those scenarios, and it's time consuming to run through every scenario, especially for each and every code change that you might make. But then there's also automated testing. So automated testing is basically testing your code with other code. There's the downside to this is there's upfront work to write functions that exercise your code and programmatically verify the outcomes. But once this code is written, the testing code is written, if you make a change, retesting is as simple as rerunning your test script. So this really saves a lot of time in the long run. There's some upfront work, but saves a lot of time in the long run. And the advantage to that upfront work is you're really thinking about all the things that you might want to consider throughout writing your code. So often writing these manual tests or these automated tests can help you in understanding edge cases to your function and really understanding how things can go wrong, basically. Another type of testing is integration testing. Integration testing tests how all the components of a program work together. So this is like testing an entire program. If it's not working as expected, it can be difficult to know where exactly the issue is coming from. But this is, like say you have a banking application, an integration test is going to be, logging in, doing some bank transfers, withdrawing money, all that stuff. That would be an integration test. But if something goes wrong there, it can be hard to tell exactly where that issue came from. And then there's unit testing, which is what we'll be going over in this course or in this lecture. So unit testing tests the individual components or units of a program. So we don't test the entire program in a single unit test, but all of the individual parts that compose that program in distinct unit tests. This allows us to identify issues in individual aspects of our code so that we can make targeted fixes to that code. And this is typically done before our integration test. So generally, what we'll want to do is we want to do a round of unit testing, make sure all the individual components work well on their own, and then we do an integration test to make sure that they work together very well. So oftentimes you'll do both. And really what happens here is you generally do a number of all of these throughout your development cycle, but generally you'll always want to do unit tests and an integration test. Check the chat real fast. All right, not seeing any questions, so we'll move on. All right, so the assert keyword. The assert keyword is really important in unit testing because it's used to affirm that a Boolean expression evaluates to true and raises an assertion error with a specific message if the Boolean expression evaluates to false. So in this particular case, what I've written here is that I'm asserting that 4 is less than 5. So remember, a Boolean expression is any expression that'll evaluate to true or false in the long run. So we often are going to use our comparison operators for a Boolean expression. So in this case, I'm using the less than operator, but we could use greater than, less than or equal to, the equality operator, any of those. And we can chain together our Boolean expressions with our logical operators, such as like and or and things like that. So any Boolean expression can be put after the assert keyword, and then you have a comma, and following that comma is the message that you want output in your assertion error when something goes wrong. So here I'm asserting that 4 is less than 5. If this assertion fails, if this evaluates to false, then we'll get this output in our assertion error, which will tell us something about what's going wrong with our code. So if I change it to assert 5 is less than 4, then we'll see here that we do get an assertion error, and it gives us the string that I had mentioned right up here. In this particular case, when I hit enter on this code, nothing happened because this assert was evaluated to true. So we didn't get any error there. It worked as expected. So just to call out again, we have our assert keyword followed by our Boolean expression, and then the string that we want, the message that we want to output in our assertion error in the case that the assertion is false. So this can be used to verify that a function is returning an expected value. So, say with the sum function, we want to make sure that the sum function is working correctly. And for whatever reason in our sum function, we're wanting to make sure that the result is 12. So in this particular case, we're asserting that the sum of 3, 4, and 5 evaluates to 12. It does in this case, so we don't get any error raised from this assertion here. But in this particular case, say we changed our 5 to a 6, now this sum is actually going to be 13. 13 is not equal to 12, so we do raise an assertion error, and it tells us that the result should be 12 because of the message that I gave here in the case that the assertion was false. So let me check the chat and see if there were any questions on that. Nope, no more questions, so I'll keep moving along. But yeah, the assert keyword is great for just making sure that things are working as expected. Generally, you're not going to have something like this, where you're just having like 5 less than 4 or 4 less than 5. Unless, say you have a variable that needs to be less than a certain value or equal to a certain value, whatever it might be in your code, you could use an assertion in that case. But generally what you're going to do in our unit test, which we'll see down the line, is we're going to test our functions somewhat like we have here. So the unit test package. Unit test is a unit testing framework inspired by unit testing frameworks from other languages. It often comes pre-installed with your Python distribution. You import it into your unit testing file as you do other packages, and it should be its own file. So you want to, your unit testing file is going to be its own distinct file separate from any of your other functions. So you'll always want to make sure that you have, say, like a testing folder, and then in that testing folder, you'll have various files that are unit testing files of various functions that are throughout your code. You don't want to put your unit tests in the same file as your other functions or aspects of your project that you've already created. So that's an important note here. Just make sure that your unit tests are always in their own file, and you'll import unit test at the very top of the file there. Once it's imported, you can create a class that is a subclass of unittest.testCase. So thinking back to previous weeks where we've gone over classes, you create a class, and in this case I've named it test list methods, and then in that we are inheriting from unittest.testCase. So this test list methods class is a subclass of unittest.testCase, and basically what happens here is that this test list methods class is going to inherit all the properties and attributes of the unittest.testCase and all the methods that come with unittest.testCase. So then we can define methods within that class to perform various tests. So within this test list methods class, I've created a method here called test sort. And remember, with methods in our classes, we always have to have the self keyword. So since this is a method of a class, we always want to pass the self keyword there. And in this test, what I'm doing is I'm taking a list, and I've just assigned it some random values, 5, 3, 5, 6, 8, 6, 3, and then I'm sorting that list. And then what I want to do here is I'm going to assert. So I'm using self.assert equal, and we'll go over various other basically methods that come along with the unittest.testCase class that we can use for testing that our code is working correctly. So here I take this list, I take my list and then I sort it. And then I want to assert that did in fact sort my list. So I do a self.assert equal, I pass my list, so my list after the sort operation. And then I pass in the sorted version of this list that my list was originally defined at, which is 3, 3, 5, 5, 6, 6, 8. And then we can also, in this method over here, we're testing reverse. So I've given it an informative name here. Generally, you'll want to start it with test something and test whatever you're testing, basically. So here I'm doing test reverse. So I take my list, it's the same list as it was over here. Then I'm doing mylist.reverse. What I'm going to do here is now I'm going to do two different assertions. I want to assert that my list isn't equal to the original list anymore. So I do an assert not equal and check that my list as the first argument is not equal to the original list itself. Then I'm also going to assert that it's equal to the reversed version of that list. So here I'm doing two assertions in here, and I'm basically verifying that the list itself was changed in place, and I'm verifying that it was changed in the way I expected, and that's that I reversed the order of that list. So let me real fast make sure there aren't any questions. All right, still not seeing any questions in the chat, but if you do have any, please enter them into the chat. I know unit testing is a pretty high level thing here, so don't hesitate to ask any questions. Great. So the unit testing package continued. Once your tests are defined, you can run them in a few ways. You can run the file itself via your PyCharm IDE, just like we've seen previously, where we run our entire files that we're writing, say for our assignments. We can do it in the same way using like the play button or right-clicking the file and clicking run. And we can also selectively run individual tests using the run button near the file line numbers. So here I have this play button here. This will run every unit test within this class. This play button here will run the unit test that's on the same line as that play button, basically. So this will run test sort, and then this play button will run test reverse. And then you can also run it from the command line using Python 3-m. -m is basically saying to call that unit testing framework itself, and then your file name. And here I have my file name as example.py. So I'm running Python 3-m unit test example.py, and that will run all of the unit tests within that file. So there's a number of different ways we can run unit tests. And just to kind of see what this all looks like put together, this is like a unit testing file here. So I have example.py as my file name. At the top, I've imported unit test, and then I've created a class, test list methods, and I've made it a subclass of unit test.testCase, passing in unit test.testCase as basically an argument to my class test list methods. And then within that, I've defined a couple test methods in here. So there's test sort and test reverse. And this is basically everything we saw on the previous slides, just all put together into one. So if we want to run, so just to call it out very specifically, if we want to run the file itself via PyCharm, just remember to make sure that you have the file selected in this dropdown, and then you click that play button there. You can selectively run individual tests using the run button near the file line numbers, like here. And then you can run via the command line as well. Cool. So the unit testing package continued. When you run your tests, you'll get an output to the console indicating the result of your tests. So if you run the whole file, here you'll see two dots appear. Those two dots indicate that the test passed. If you see like an F in there, the F will indicate that your test failed. And then you see the number of tests that was ran. So it says ran 2 tests, and it tells you how long it took to run those tests. And the OK here indicates that everything ran just fine. So if you ever see an F up here, you'll see that something went wrong, and we'll see that here on the next line. So if any of your tests fail, the test report will say so. So say that I comment out my test reverse in my test reverse method. I comment out the mylist.reverse. So now I'm not actually doing anything with the list. I'm not actually reversing it. So this assertion, both of these assertions would fail. The first one to fail is going to be the one that causes a failure in our report. So we'll see that here. So see in this case, we see an F in place of the first dot. And that was because test reverse was the first method in there. So we see an F in the first place. And then the other one is still a dot. That means that the other test still passed. So I didn't screw up my test sort method. So test sort is still passing. That's why we get a dot, but we get an F because test reverse is now failing. And then it'll give you an indication of what's going on within there. So we see that it says fail, test reverse. So it's telling us which method failed in our testing file. And it's in our example, which is our file name, .testlistmethods, and testlistmethods is our class there. So we have our method name, the file name dot the class name here, and it calls out that we got a failure. And then we get a traceback here, indicating exactly what happened in that failure. So it's telling us in our example.py file on line 14 in test reverse, the line self.assert not equal. So this line here, because it was the first one encountered, so this was the first assertion to fail. And that line, we get some error here, and this is the exact line of code that I have up here. Self.assert not equal my list, and then the list that I wanted to assert it's not equal to, which was basically the original list because it was supposed to have been reversed. And then we get an assertion error, and it calls out that this is still equal to this, but our assertion was assert not equal, so that's where we get an issue there. And then we still have here that it ran 2 tests, and it ran it in 0.000 seconds. So just like up here, but now instead of the OK at the bottom, we see failed, and it calls out the number of failures. We got 1 failure in our file, and that was for test reverse. So it gives you a pretty detailed report of exactly what happened here, and it helps you find exactly where the issue went wrong. So you can get into the exact method, the file, the class. To say you have multiple classes in your testing file, or multiple methods in your testing file, or multiple testing files, and you want to know which one failed, and then it calls out the exact line that it failed and what the failure was here, and then down here it tells you the number that failed, which is great. Then we can easily go in and identify what our problem is. In this case, the test case itself is badly written. I commented out my list.reverse, but in most cases, what's actually going to happen is that this indicates some problem with your code. So you're going to want to go look at your code to identify how your code resulted in the assertion error. So let me go back and then check the chat. All right, still nothing in the chat, so I'm just going to keep moving along, but please, if there are any questions, feel free to come off mute and ask, or put your questions in the chat. Great. All right, so unit test methods. So the unit test package comes with a number of built-in methods to use in your unit tests. And in order to use these unit test methods, you need to make sure that your class that you've created is inheriting from or is a subclass of unittest.testCase, because these methods are actually defined under unittest.testCase. So in order for you to use them, your class needs to be a subclass of unittest.testCase. So there's a lot here. We've seen these two in the examples so far. So we have assert equal, we have the actual value, the expected value, and a message. So with all of these, the last thing that you can enter is a message, and that message will be output to the console in case of a failure. So, back here, what was output to the console was just, how the assertion error was raised, basically. It was just saying that these two values are equal, not terribly informative necessarily, unless you know exactly what might be going wrong in your code. But say I wanted a more specific message, like saying, the 2 lists are equal. It was expected that the actual list was going to be reversed, but instead it's not, things like that. Yeah, so we can assert, so this asserts that the 2 values are equal. So the first value here is equal to the second value here. And then we can, have some custom message, and this message is optional. Assert not equal, same thing, actual value, the unexpected value. So what you don't want this value to be equal to, and then a message, and this asserts that the values are not equal. We have assert false. So this is like, just saying like, checking if something is false. We can have a Boolean expression in here, or a variable that would store a Boolean value, and it asserts that a Boolean or a Boolean expression is false. Assert true asserts that a Boolean or a Boolean expression is true. Assert in. So with assert in, we have a value, and then we have a container. So say we have like the element 1, and then we have a list that contains numbers. And then this asserts that the value is a member of a container object. So if we wanted to assert for whatever reason that the value 1 is in a list, we can assert that 1 is in a list there. So the first argument would be the value that you want to make sure is in the list that you're passing as the second argument to assert in. So assert less, you want to assert that a certain value is less than another value. It asserts that the first value is less than the second value. Assert less equal. So this one is like assert less, but it's also checking equality. So you're making sure that the first value is less than or equal to the second value. Assert greater. This one will assert that the first value is greater than the second value. Assert greater equal, asserts that the first value is greater than or equal to the second value. So similar to the assert less equal. Oops, did not mean to do that. Assert is instance. So in this case, you can assert that the first parameter is an instance of the object type passed in the second parameter. So say for whatever reason, you have a function that returns a list, a list data type, and you want to make sure that it's returning a list data type. You could, put the return value here and then check that it's a list object type. And if it's not, it'll raise an assertion error. Otherwise, we'll be good to go. So that's a good way to check the typing of things, because in Python, it's not strictly typed. So oftentimes you can end up accidentally returning values that you didn't expect. But say you have a function that needs to always return a list, and you want to make sure that it is always returning a list. There isn't any case where it's returning none or returning a dictionary or whatever it might be. So that's where you would use something like assert is instance. And then just one final call out, the message parameter is used to specify a custom message in the case that an assertion error is raised. So, as we saw on the previous slide, if you don't pass that message, then Python will generate its own sort of message, but oftentimes it's really beneficial to have a custom message there. It looks like someone has put something in the chat, so let me see. Can you please explain again the not equal assertion? Yes, absolutely. So the not equal assertion, it basically just asserts that the two values that you enter as parameters to assert not equal are not equal to each other. So say that you have a function that returns a number. Say that it is always supposed to return an odd number or something like that. Then we could check here that the actual value returned mod 2, and maybe I'm getting a little too technical here with asserting that the value is an odd number, but you could use this to assert that the value mod 2 is equal to your expectation of the definition of an odd number. So say for whatever reason, let's just change that up a little bit. Say for whatever reason, you have a function that's always supposed to return a very specific string, and based on a parameter that you pass in. So thinking back to the function that I had created in the functions slide, where I had the function of say hello, and you pass in a name and it says hello to that name. Say I just want to make sure that the value I pass in, or what's returned by that, isn't equal to hey to that person. So then the actual value returned would be the value returned from the function, and then the unexpected value is that it's saying say goodbye to that person. Because our function is supposed to always return hello to that individual, we want to make sure it's not returning goodbye to that individual. So we make sure that the return value from that say hello function is not equal to goodbye to that individual. And that's just one example. This can be used in a multitude of different ways. Basically, just whenever you want to make sure that two values aren't equal to each other, you can use assert not equal. I hope that helps to clarify your question a little bit. Please let me know if not in the chat, and I can circle back. All right, I'm not seeing any other questions in the chat, so we'll just keep moving along. But yeah, please keep them coming. It's a great question. Always happy to go over these things again. There's a lot of information here, so don't hesitate to ask. All right, so now we're really going to get into the meat of it, testing our own custom functions with unit tests. So you can test your own custom code via the unit test package by creating a testing file and importing the functions you'd like to test into the testing file. So in this particular case, this is basically what I was just talking about on the previous slide. So say I have these two functions in program.py. I have get user greeting, and it accepts name and a greeting. And remembering back to the functions lecture, if greeting is in all of this stuff here, then return the greeting, comma, the name that we're greeting there. And then get integer quotient and remainder. It accepts a dividend and a divisor, and it returns the floor division of dividend floor divide by divisor, and dividend modulus the divisor, which is this gives us the remainder. This gives us the integer division, basically, or the floor division of that function there. So These are the two functions that we now want to test in our own custom way, since these are our own custom written code. So then we can import. The first thing we'll have to do in our test program, and oftentimes, just a quick note on naming conventions here, oftentimes what you'll want to do in your testing file is name it test underscore the file that you're testing. So here I'm testing the program file, so I name it test underscore program.py. This makes it really easy for people to recognize, like, okay, this is the test file for the program.py file. So remembering back to our packages lecture, we can import things from our other file using like the from. So from program. So I'm importing from program.py. I want to import get integer quotient and remainder and get user greeting. So that's the first step that we need to do when we're going to test our own custom functions. And let me see. It looks like there's a question in the chat. So let me check that. Okay, perfect. Not a question, just a statement. Thank you. I'm glad that helped to clarify things. Great. Yeah. So this is the first step we need to do. Import your functions from your other file. So now, once you've imported your code into your testing file, you can use them within your testing class to validate their functionality. So I've created another test class. This test class is called test program functions. And again, it's a subclass of unittest.testCase. So then I create test get integer quotient and remainder. So this, really calls out it's test underscore and then the name of the function that I'm testing. And then test underscore the name of the function that I'm testing. So I have test get integer quotient and remainder and test get user greeting. So it looks like I actually messed up the namings of these because it looks like within my code here, I have I'm testing greeting within test get integer quotient remainder, and I'm testing get integer quotient remainder within my test get user greeting. So just imagine in your mind that I got that one right, but it's an easy mistake to make. But it's something that you should definitely make sure you do right whenever you're writing your own code. I'll try to take a note to fix this going forward. But in this one, let's assume this one was called test get user greeting. So here I'm getting a greeting. I'm passing in get user greeting. I'm passing the argument world, and then I'm asserting. I'm using self.assert equal greeting hello world, and I'm asserting basically that my greeting here is going to return hello world. If it doesn't, I'm passing this message that says unexpected greeting returned, expected hello world, but got, and then I'm using string formatting to insert the greeting that I actually got back into these squiggly brackets here. So it'll tell us, that like we expected hello world, but instead we got something else. And then in this one down here, let's again imagine that this was called test get integer quotient remainder. I am calling get integer quotient remainder with 10 and 3 as my arguments. So 10 is the, let me just remember here, 10 is the dividend, 3 is the divisor. So I want to assert that my quotient is an instance of int. So I want to make sure that quotient is returning an int, because remember with floor division, that always returns an integer. In this particular case, we want to make sure it's an integer, not a float, because if we wrote our code poorly and it was returning the raw division rather than the floor division, we would get a float back instead of an int. So here I want to make sure that I am getting an int back, that I'm correctly doing floor division. So I'm asserting that quotient is an instance of int. If it's not, then the message I'm going to output is expected quotient type to be integer, but got, and then I'm formatting in the type of the quotient here. So this would, call out if quotient was a float or something like that. I'm also asserting equal that my quotient is equal to 3. So since I passed in 10 and 3, 10 floor divided by 3 is 3. So I'm asserting that the floor division is working correctly here, and otherwise I'm going to output a message that says that the expected quotient to be 3, but instead we got whatever the value of quotient is. And then in assert equal, I'm asserting that the remainder is equal to 1, because 10 floor divided by the 10 modulus 3 is going to be 1. So the remainder of 10 divided by 3 is 1, because 3 goes into 10 evenly 3 times. And then the remainder there is going to be 1, because 3 times 3 is 9. So 10 minus 9 is 1, basically. A long way to get there. But anyway, then I'm asserting equal that the remainder is 1. And if it's not, then I'll output expected remainder of 1, but got, and then whatever the value we got back for the remainder is there. So this is how we can test our own code, using testing our own custom code using the unit test framework. And this is really what you're going to be doing in most cases. The examples that I used earlier of testing list methods, you can kind of expect that those are all going to be working as expected, because those are built-in functions. There's no need to write unit tests for those things. So just keep that in mind. All right, I'm not seeing any questions, so I'm going to keep moving along. But if you have any, please do ask in the chat. All right, so that's really it for the lecture today. So some additional resources here, getting started with testing in Python. Highly recommend reading this. Testing is a very high level thing. It can be very complicated and confusing and hard to wrap your head around when you first start. So please do some extra reading on this. It only stands to help you. Unit test documentation. So unit test is the package that we talked about throughout this lecture. And you can read all the documentation for unit test at this link. So it can be a little, complicated to read through documentation, but I think it'll benefit you all to just get used to reading through documentation, because that's going to be the best way for you to learn new things going forward. This being the last lecture actually of this course. Of course, we're still going to have meetings after this, but this is really the last learning lecture that we're going to have throughout the course. The rest of it, you're going to be working on projects. So you'll want to get used to reading through documentation, because in your own self-learning and self-study going forward, you're going to be reading a lot of documentation. So I highly recommend giving this a try to read through. And if you have any questions on it, let me know, and I can help to sort out, best ways to read through documentation and things like that. And then another unit testing framework that is very useful is PyTest. So I have the PyTest documentation linked here. So PyTest is kind of like unit test. It's built basically on top of unit test. And it's another great unit testing framework. Basically what you can do with PyTest is you create your unit tests. You can create unit tests, and then you can run them using PyTest. There are a couple advantages to PyTest. But one of the downsides is it doesn't come built in with Python, and that's why we didn't talk about PyTest here. You will have to install PyTest separately, but it is, in some ways, some people would argue it's a better unit testing framework, but both of them are going to get the job done there. So don't worry too much about it for now. Just focus on unit test. But if you do want to explore another unit testing framework, and you find that there are some limitations to unit test, which I doubt you'll find any limitations to it where you're at right now, but eventually you might, then you can look into other unit testing frameworks like PyTest. And these aren't the only ones. There are other unit testing frameworks as well. These are just the ones that I use on a regular basis. Great. All right, so I don't see any other questions in the chat so far. So let's go over the assignment. All right, so the assignment this week, and this is really the last assignment for the class aside from your projects. So your projects will, in a way, be one big assignment, but you'll be working on it on your own. But anyway. All right, so week 11 assignment for unit testing. For the assignment this week, we are going to go back to our assignment from week 8 on functions and create unit tests for the functions created in that assignment. Using your own submission for week 8, create unit tests to verify the functionality of the code you wrote, making sure to cover the following test scenarios. For the function created as the answer to question 1, verify that your code works with different multiplier values, minimally including 0, 2, and 5. Also testing that your code works with different lists, including lists with varying sizes. And then for the function created on as the answer to question 2, verify that 32 degrees Fahrenheit is converted to 0 degrees Celsius. Verify that 77 degrees Fahrenheit is converted to 25 degrees Celsius. And at least one other test scenario, come up with your own test scenario. But yeah. For the function created as the answer to question 4, and I think that question 4. Let me actually really quickly pull up because I know I had changed week 8's assignment to have some extra credit in it. So I want to make sure that I'm not, okay, yeah, so question 4 and 5, those were extra credit. So if you decided not to do the extra credit for that assignment, let me know. I will give you the answers to 4 and 5 so that you can write your own unit tests for those. But something I do want to call out is that I will give you that I'll give you extra credit on both this assignment and the previous assignment if you do both. Or sorry, I'll give you extra credit on I'll retrospectively give you extra credit on assignment 8 if you go in and write these yourselves without asking me for the code. Anyway, so back to the assignment. So for question 3, for the function created as the answer to question 4, verify that 0 factorial equals 1, verify that 4 factorial equals 24, and at least 3 other test scenarios. Again, if you didn't actually do this question since it was extra credit, let me know. I'll give you the code. But if you want to take the time to write the code yourself, I will give you the extra credit retrospectively for that assignment. All right, and then for question 4 in assignment 11, for the function created as the answer to question 5, and again, same situation here. If you didn't do this as the extra credit, let me know. I'll give you the code, and you can do your testing there. Verify that units passed in feet are converted to meters. Units passed in inches are converted to meters. Units passed in meters are converted to feet. Units passed in miles are converted to kilometers. Units passed in kilometers are converted to miles. Units passed in fluid ounces are converted to milliliters. Units passed in milliliters are converted to fluid ounces. Units passed in gallons are converted to liters. Units passed in liters are converted to gallons. And then passing 1 foot returns 0.3048 meters. Passing 12 inches returns 0.3048 meters. Passing 3,048 meters returns 10,000 feet. Passing 1 mile returns 1.6039 kilometers. Passing 1.6039 kilometers returns 1 mile. Passing 1 fluid ounce returns 29.574 milliliters. Passing 30 milliliters returns over 1 fluid ounce. Passing 1 gallon returns 3.7854 liters, and passing 4 liters returns over 1 gallon. And then as a bonus, so I'm just going to rename this to extra credit. So in order to get extra credit for this assignment, you'll need to do question 5. The rest of this is required for basic credit. Anyway, so extra credit on question 5, update the function from question 3 to return instead of print recommendations, then verify that both 30 degrees Fahrenheit and -1 degree Celsius return it is probably best to stay in today, and verify all testing scenarios you can think of, i.e. all combinations of temperature, temp and weather that would produce distinct outcomes. So this one, I'm actually going to allow, if you do all of this, so if you just do this one here, each of these basically will be worth a quarter of an assignment worth of extra credit, because I want it all to, throughout the course, eventually add up to 1 whole assignment of extra credit if you do all the extra credit opportunities. So if you do just A here, great, that'll get you a quarter of extra credit because it's going to require updating your function and then writing test cases for that. But if you do both of these here and you take the time to verify all the testing scenarios you can possibly think of, then I'll give you basically a half of an assignment of extra credit here. So big opportunity here for extra credit. You can get a half assignment worth of extra credit by doing all of question 5 on this assignment. And if you haven't already, you can go back to assignment 8 and complete questions 4 and 5 yourself. And I will give you another quarter assignment of extra credit. But if you don't want to take the time to do that, I completely understand. For questions 3 and 4, if you didn't do 4 and 5 in assignment 8, I will give you the code for that. Just know that you will not be able to get the extra credit on assignment 8 at that point, but you can still get the extra credit for this assignment here. Cool. So any questions? I know that was a ton of information. All right, I'm just going to put some notes in here. 0.25 points extra credit. Just to call out that, each of these are worth 0.25 points of extra credit. Great. Well, I'm not hearing anything, and I'm not seeing anything in the chat. So I guess we'll actually have some extra time today. One thing I do want to talk about, since we're finishing a little early today, is that next week we will not have lecture. So let me actually pull up the syllabus. So next week, September 18th, we have our mid-course break. We're basically halfway through the course at that point. We will not have lecture. Assignment 11 for unit testing will not actually be due until September 25th. So you have 2 weeks for assignment 11. And also, if you have any other assignments that you haven't completed yet, or you haven't turned in, or you haven't gotten full points on, please make sure to submit those by September 25th. By the time we get to the point of working on our projects, we won't be accepting any more submissions of assignments. So please take the next week, which we'll have off, and basically the next 2 weeks where you have 2 weeks to work on assignment 11, and we won't have class next week. Please take that time to work on any assignments that you haven't completed yet so far and submit those once we actually get into basically by October 2nd. If you haven't already submitted all of your assignments, you're not going to be eligible to get any credit for those assignments at that point. So we need to make sure that you've really learned everything that is required for the course so far and required for working on your own projects before you really start working on your own projects. I don't want everyone working on, and I don't want anyone working on assignments from the first half of the course during the second half of the course where you're really supposed to be dedicating that time to working on your own final projects. So on September 25th, you'll want to start thinking about project ideas that you're going to be doing for your final project. Come to the class with ideas, and we will review those on September 25th. So thanks everybody for your time. I hope you all have a great rest of your weekend and an awesome upcoming week. I will talk to you in 2 weeks. So have a good one. Thanks.